Welcome to the IBM Predictive Maintenance and Quality Demo. My name is Ishan Sehgal. I'm the Program Director of PMQ Product Management in IBM Business Analytics Software Group. Let's start with the dashboard. Represented here is the zoom in of the main PMQ dashboard, where we show the overall summary level view of the assets that might be measured or monitored by PMQ. Here we show assets located in 4 different locations with the average health score shown and the number of resources or assets in each location. We can see in San Francisco that there is a single asset there, and that asset has a low health score. You can see down below that there is a single asset, drilling machine number 11, shown in red, and we might want to investigate that further. Before we go deeper into the Cognos reports and how these are generated, let me do a little bit of setup of what we're looking at and how that data is being captured. So here we have a representation of a generic field asset. It's a drilling machine. There's several different measurements that we're looking at. Here, an example of that is an RPM. Another example might be the extension length of the drilling. Another example is the angle of attack. Another might be the tip temperature, the temperature of the drilling tip itself. And also external data that's not connected to the machine itself. Here, an example of that is weather or ambient temperature. There could be other examples of external data like personnel information or HR data. All of this combined could play a factor in the health of an asset. Along with measurement data is alarm data and log data. Here we see a low hydraulic pressure alarm. Let's see what happens as this scenario progresses. The asset manager is busy trying to monitor a lot of data, whether it's measurement data, log data, sensor data of all types. There are some alarms coming in. In this case, this hydraulic alarm is something that comes in quite often, and they most often ignore it because if there really is an issue related to fluid, such as a fluid leak, it's a little bit easier to detect, and so they usually ignore the hydraulic pressure alarm. They know that they would get behind schedule if they had to look at each and investigate each one of these alarms. They don't have enough maintenance personnel to look at them anyway. Secondly, if those assets were brought down for maintenance, that would have downstream impacts. In the meantime, there is an actual failure. The whole asset is offline. The maintenance manager is saying that it's already they don't have a part in-house. It's going to take another 24 hours. And the ops manager is worried that he's already behind schedule. Meanwhile, the asset operator himself might be enjoying a cup of coffee. This asset manager is thinking there's got to be a better way. There's so much data coming in. There's occasional alarms, not knowing what to do with them, mostly ignore them until an actual failure occurs, and then they have to react. Where could predictive analytics play a role? Well, predictive analytics would be used to understand their data environment. They could see a failure analysis and provide a predictive model for that and find patterns. The software looks for correlations of all kinds, looking at various measurement data from multiple sources, and identifies patterns for that. Here in this analysis, we did find that the low hydraulic pressure contributes to failure when the ambient temperature is high. We also see that high temperature contributes to failure when a particular type of hydraulic fluid is being used. This hydraulic fluid also plays a factor in a asset failure when the seal is old. This is what we call a multivariate analysis, and a single human cannot look at all the data and do this analysis in their head. There are several variables that occasionally come together that might cause an actual failure, and that could be potentially used to predict a failure. Here's where IBM Predictive Maintenance and Quality come in. That once you do that ad hoc analysis and understand what are the variables and how those might contribute to a failure, you take a look at implementing that in a operational environment. But as in any environment, it's not just relevant or important to have a model that predicts a failure. You also have to have an actionable result. And here, in this example, the operators know that they could perform a simple flush procedure that would require minimal downtime. This flush procedure cools and softens the seal, and by knowing which of the fluids the machine is running and the age of the seal, the predictive model can tell us exactly when this flush procedure would be helpful. So let's go back and see how IBM PMQ would have helped in avoiding this costly failure. So we're measuring all this raw data coming in, the RPM, the extension length, the tip temperature, the fluid manufacturer type, the ambient temperature, humidity, hydraulic pressure, seal age. There could be many more dozens or hundreds of other measurements coming in. And what we do, and this is very important because this applies across industries, across asset types, and across processes, is that we're pulling in all this data in real time, and we're providing we're aggregating it and profiling it into an asset profile. Here we do our KPI and calculations very quickly. Here we're doing some simple ones, the min, max, average, last, and we're storing only that data, that profile data, in our data store. Once we have that profile available for each asset in real time, we're able to take that profile data and run it through our predictive model. In this case, the model is calculating the health score. The higher the score, the better. And also in this case, at this time, the health of this machine is good. As time goes on, the profile is getting updated, the predictive model is being run in near real time, and the health scores are provided in near real time. Later in the day, the ambient temperature is getting hot, and the sun is out there. The other variables are changing. The profile has gotten updated on a regular basis, and so has the predictive score. Here, the score now has gone down to 50. So let's see what would happen. Well, our rules that we talked about earlier is that that simple flush routine should be performed when the score drops. Here, the rules are looked up inside of our tool, inside of PMQ, and the flush procedure is recommended. That recommendation could be automatically routed to a Maximo type environment so that a new work order is assigned to the appropriate technician for urgent action. So let's see how that would look back in our PMQ environment. In this demo, we'll start with a dashboard that we looked at earlier, and we'll have a data simulator that is actually simulating real-time data. This is an important point in that what PMQ has been designed to do so well is capture all kinds of data in real time, aggregate it, summarize it, and perform the analytics and provide a recommendation. In this case, we'll be running a simulator to run a baseline of humidity. Then we'll we'll arbitrarily increase the humidity and see what happens. We'll also show temperature being measured, and we'll also increase the temperature and see how that impacts the health of the machine. We'll also see if that triggers a work order and show that in Maximo. The different administrative tasks that are part of this are the integration bus capability, the decision management rules, the predictive modeler using SPSS modeler, and master data management.